Hello, everybody. Today I'm going to go through the teacher's notes for the volume of prisms. And I'm going to try something a little different today. I'm going to use two different cameras, and I'll switch back and forth between being able to look at you, see you right there, and then showing you my whiteboard so that you can see me work on these problems as we go. So let's make sure it's pointing in the right direction. Yep, that's a smiley face. Okay, so let's go. So we're going to do volume of prisms. So remember what area is. Area is like the amount of space a two-dimensional object covers. So if you think about my whiteboard right here, and if we think about counting the squares in my whiteboard, the square area, okay, it would be 1, 2, 3, 4, 5 times 1, 2, 3, 4, maybe 5. So 25 or 20. I don't know. Let's just say it's 25. 5 by 5, 25 square areas is the surface area of my whiteboard. But volume is different. So remember that area is measured in the units are square. Volume is different. Volume is the amount of space that's taken up in a three-dimensional object. So imagine my glass right here. Okay, I'm going to switch cameras so you can see my glass of juice. So imagine my glass of juice right here has some volume in it. If it was completely full, if I poured all of this volume on my table, it would probably cover my whole desk. So volume is different, and it's measured in a cubic amount, cubic units. So we'll have like centimeters third to the third, or centimeters cubed, or inches cubed, or cubic yards, or something like that. So it's the volume of a three-dimensional space. Volume is the amount of units taken up by a three-dimensional space. Okay, so we're going to study three different kinds of prisms, or three different kinds of three-dimensional objects. So usually with a prism, always with a prism, the end tells you what kind of prism it is, or the base. So for example, here's this is a two-dimensional picture. Here's a triangular prism that I made right here. Okay, I'm putting it on my whiteboard so you can see it. Here's a triangular prism that I made, and the face on the end tells you what the shape on the end tells you what kind of prism it is. So this is it's a triangle on the face, and it's a three-dimensional prism. Okay, so the base tells you what kind of prism it is. So this might be a trapezoidal prism. This might be a 1, 2, 3, 1, 2, 3, 4, 5, 6. This might be a hexagonal prism. Cube is a special kind of prism. Okay, so all the sides of a prism are flat. There are no curves. So the cylinders are something different. The cross section is the same. So if you were to cut into each one of the different layer in each one of these prisms, the cross section would always be the same as the face. So this trapezoid, or if you were to cut into my triangular prism, if you were cut into little slivers, each piece would be a triangle, and it would have the same size triangle. Okay, and the name that refers to the object's base, example, rectangular prism, triangular prism, that's the base that we're talking about. Okay, so that's a prism. So let's name each one of these. So this one might be a rectangular prism. So this first one, we have a rectangle as the face, and it would be a rectangle all the way across. This one would be a triangular prism, so the base is a triangle, and every sliver that you cut is the same triangle. Here's another view of a 1, 2, 3, 4, 5, 6 hexagonal prism. So every sliver that you cut through would be a hexagon of the same shape, same surface area, or the same area. Okay. So when we're to find the volume of a prism, it's actually really a very familiar formula. It's base times height. But instead of being a regular small b, this is an uppercase B, and it's an uppercase B for a very important reason. It's because we're trying to remind you that this is the area of the base. So when we're finding the volume of a prism, we're always going to find the area of the base, that's the big B. Then we're going to find the height of the prism. So if we were to look at this triangular prism, we would start out by finding the area of this triangle, that's the base. And then we would find the height, so that's the distance from one base to the other base. So you might think of it this way, or it's a little difficult to see if I turn it sideways, but it's the height of the prism from base to base. That's the little h. You multiply those two numbers together and you found the volume. So it's an easy formula to remember for finding prisms. You just have to know how to find the area of the base, the different kinds of bases that we'll have. Okay, piece of cake, right? All right. Find the volume using V equals BH of this, this prism right here. So this is a triangular prism, and I'm going to work through this as we go. So how do we find, remember, volume equals big B times H, and big B equals the area of the base. Okay, so how do we find the area of a triangle? So area of the triangle equals 1/2 base times height. Remember, that's a little b. Okay, so we're talking about one of the sides. So the area of this triangle right here that we're looking at. So let me get my special little highlighter thing. This guy, I think I like him. So the area of this triangle is what we're trying to find. And the base is 12 meters. So I'm going to start filling out 1/2. And the base is 12 meters. And the height of this triangle is, what is it? The height of this triangle is 16 meters. Okay, so 16 meters. All right, and now I can find the area of the triangle. I'm going to make this a little smaller so we can, I don't have to toggle back and forth. Okay, so the area of the triangle is 1/2 base times height, 1/2 times 12 times 16. And you know I can multiply that in any order I want. So 1/2 times 12 is 6. And 6 times 16 is 36, 96. 96. And the area is in square units, and it's meters, so meter squared. Okay, did I do that right? Half of 12 is 6, so 16 times 6. 6 times 6 is 36, carry the 3, 96, yeah, pretty good. All right, so that's the area of the triangle, but we're not done yet. We're trying to find the volume of the whole prism. We're trying to find the volume of this whole guy right here. And now all we have to do is come back here. So we're going to plug in 96 in for our base. V equals 96 times H. And H is 20 meters. So 96 times 20. And let's see, that's going to give us 192. That would be 200 minus 8. Yeah, 192 with an extra 0 on it. So let's do this times 20. Okay, so I'm just going to multiply times 2 and add a 0 on it. So 2 times 6 is 12. There's 1. 2 times 8. 2 times 9 is 18, plus 1 is 19. So 1,920, the volume equals 1,920. And remember, this is a cubic measurement, and it's in meters, so we're going to write meters cubed. Okay? If you didn't follow all that, that's the beauty of videos. You can back up and watch this all over again. But you can see all my calculations there. Find the area first, area of the base, that's big B, and then H, and just multiply. Okay. Find the volume using V equals BH. And what is this one? This one's a rectangular prism. And so we have this cool little rectangle here as the base, and it's 9 centimeters wide and 4 centimeters tall. So we're going to say the first thing we're going to do is find the area of our base. So the area of the rectangular base equals base times height is 4 times 9. So that equals 36. And that one's a square measurement, so centimeters squared. So the area of the rectangle is 36 square meters. Centimeters, sorry. So now we need to find the volume. The volume is equal to, we're going to replace that 36 in here for our big B, so 36. And the height of our rectangular prism is 5.4 centimeters. Okay, so we're going to multiply that times 5.4. All right, I can't do that one in my head, so 36 times 5.4. 4 times 6 is 24. Carry the 2. 4 times 3 is 12, plus 2 is 14. Let's start with a 0. 30. Carry the 3. 5 times 3 is 15, plus 3 is 18. So I have 4, 4, 9, 1, and 1 decimal point. Sorry, 1 decimal point. So my volume is equal to 194.4, and it's, remember, cubic units, so centimeters cubed. Okay, so refresh. I found the area of the base of the rectangle. That's this calculation right here, the area of the rectangular base. And my handwriting is terrible, so it should say 4 times 9. 4 times 9. And we got 36. And then we multiplied that times the height of the rectangular prism. Okay? Piece of pie. Let's try another one. So this one's a trapezoid. Probably going to need a little bit more room. This one's a trapezoidal prism. And so remember that we have V equals big B times H. And what's the area of a trapezoid? Anybody remember that one? The formula for the area of a trapezoid. So big B is going to equal 1/2 times base 1 plus base 2 times H. Wow. Okay. So what do we have over here on our trapezoid? We have base 1 is 14 centimeters. Base 2, it's the parallel side opposite. The bases are the parallel sides that are opposite each other. So 14 centimeters is B1, 8 centimeters is B2, and then the height of our trapezoid is 4 centimeters. So I'm going to fill that in over here. I'm going to have the area of our base is 1/2, and 14 plus 8 is 22. So you saw where I got that. 14 plus 8. So I had my base 1, 14, and then I added base 2 is 8, 22, and my height is 4. So 1/2 of 22 is 11 times 4 is 44, and the units are centimeters, and area is squared, so centimeters squared. Now I can calculate the volume of my prism. So volume is going to equal, I'm going to plug in my 44 for big B, and the height of my prism is 10 centimeters. right there, 10 centimeters. So I'm going to multiply times 10. So 44 times 10, that one's easy, 440. And what are the units? Centimeters cubed. Remember, volume is always going to be a cubic measure, cubic units. Okay? Great. So you can always pause and go back and look at that example again. But let's go on. So we're not always just going to ask you for volume. We're going to be tricky. We're going to ask you, we're going to challenge you to find other values given volume or given one of the components, okay? So remember that V always equals BH, big V, H. And so we have what kind of prism do we have here? The base is a triangle. So it's a triangular prism. And so we need to find the height of the prism. So we need to find this dimension right here. What's the length of that edge right there? If we know that the volume of the prism is 90 cubic centimeters. So we know that V equals 90. I'm going to start plugging that in. And BH, it's a triangular prism. So 90 equals 1/2 times little b times h of the triangle, and then h of the prism. Okay, try to keep track of my heights here. All right, so I'll start plugging things in again. 90 equals 1/2, and little b of our triangle is 6 centimeters. 6 centimeters. And the height of the triangle is 3 centimeters. And the height of our prism is unknown. So we're going to just put HP there. Okay, so I can multiply through. I get 1/2 of 6 is 3. 3 times 3 is 9. So now I have 9 times HP equals 90. Oh, boy, easy math. So I'm going to split it in half, isolate the variable, which is HP, opposite operation. So I'm going to divide by 9 on both sides. And I have 10 equals HP. So what is HP? What's the units on HP? Is it cubic? No, because it's a distance. We're just showing the distance between the base. The height of the prism is the distance between the two bases. So we're finding this edge right here, and that is just a distance measure, and so it's going to be in centimeters. So our answer is H of the prism is 10 centimeters. Okay, piece of pie. Let's look at the next one. Wow, that was it. Volume of pyramids. Oh, so now we're going to move from prisms on to pyramids. So pyramids have a little bit different formula because their shape is different. So let's take a look at a pyramid. What do we mean by a pyramid? A pyramid can have a square bottom with sides that go to, they slope into an apex at the top. So they can have a square bottom, they can have a triangular bottom or base, or they can have a hexagonal base, but still you need to know what is the area of the base. So they're defined by the name of the pyramid is defined by the face that's the base. Okay, so a square pyramid or a triangular pyramid or a hexagonal pyramid. Okay, so let's dig in. Prisms have two equal parallel bases. Sides are rectangles. Pyramids have one base and one apex. So one base down here and one apex up at the top. And the sides of pyramids are always triangular. Okay. All right. So what's the difference in volumes? Let's watch this little video. Boy, I hope I can play it. Let's watch this little video. Boy, I don't know if it's going to let me play it in this. This is a really cool video. If I can't play it here, I'm going to, oh, here it goes. So starting with square-based pyramids. Oh, no, it's a triangular base. No, it's a square-based pyramid. Okay, so we poured that into a cube. How many would you get into that cube? Oh, wow. Two little ones and a giant one? Oh no, it's an optical illusion. So 3 pyramids fills up 1 cube. Very cool. All right, so let me see if I can go back. Oh boy, how do I get back? There we go. All right. Oh, don't play anymore. Don't want you to play anymore. Okay, so that little video should really help you remember the volume of a pyramid. Come on, little guy. Technical difficulties, I'm sorry. Here we go. The volume of a pyramid. So remember our prism was V equals big BH. The volume of a pyramid is 1/3 big BH. So you got to do the exact same thing. The area of the base times the height of the pyramid, and then times 1/3. And that gives you the volume. This is so easy. Okay, so let's calculate one. Find the volume using V equals 1/3 base times height, big B times height. And what kind of base is on this pyramid? What is that shape down there at the base of the pyramid? It's a square. So 8 centimeters on each side. So the area of the base, so big B is 8 times 8. So 8 times 8 is 64. And that is centimeters squared. Remember, area is always square units. And the volume, the height, the volume is equal to 1/3 times the area of the base times the height. The height of our pyramid is 9 centimeters. So volume equals 1/3 times 64 times 9. 1/3 of 9 is 3. 3 times 64 is 192. 192. And we're doing volume, so it's centimeters cubed. So the volume of our pyramid is 192 cubic centimeters. Piece of cake, right? All you got to remember is that 1/3. All right, find the volume of this pyramid using V equals 1/3 BH. And what kind of base do we have on this pyramid? The base is a triangle. And the area of a triangle, so remember, volume of a pyramid is 1/3 big BH. Big B of this pyramid is a triangle. So the area of the base, which is a triangle, is equal to the base of the triangle, which is 17 inches. 1/2 times 17. And the height of the triangle is 10. So times 10. So 1/2 times 10 is 5. 5 times 17 is 85. So 85 inches squared. That's the base of our triangle. And the volume equals 1/3 times 85 times the height of our pyramid. The height of our pyramid is 20 inches. 20 inches. So we're going to multiply those three things. So let's see. I don't see an easy divide by 1/3. So let's just multiply it out. 85 times 20 is 170 with the 0 on the end. So 1,700, and 1,700 divided by 3. So 3 goes into 17 5 times. So 5 times 3 is 15. So subtract, I get 20. That goes in 6 times, 18. So I'm going to get repeating 6s, 566.6. So volume equals 566.6 repeating inches cubed. And there you have it. Okay, folks, if you have any trouble with any of these calculations, let's see, was there one more? Let's see, was there one more? Uh-oh, there is. Let's do that one. This one says, find the width of the pyramid. See, I told you, we weren't going to let you off easy on these kinds of problems because they're really simple math, right? Once you know the formula. Now we got to make you think. Find the width of the pyramid using V equals 1/3 BH if the volume is 112 cubic meters. Okay, so you can't assume that this is a square because it can be a rectangle, right? Right, so we have to calculate. And the volume equals 112. So we'll start out with our formula. V equals 1/3 big BH. And so we said that our volume is 112 equals 1/3 big BH. I'm going to go ahead and get rid of this fraction. So I'm going to multiply both sides by 3. So 336 equals big BH. So I just multiplied both sides by 3, and that gets rid of that fraction, right? Okay, now, what do I know? I know that the height of my pyramid is 6 inches. Okay, so the height of my pyramid is 6 inches. So 336 equals big B times 6. Okay. And I don't know what the area of the base is. I'm trying to find out what this side over here that doesn't have a label on it, what could that be? So I know that the area of a rectangle is length times width. So I'm going to plug that into my formula for B. I'm going to say width times 7 times 6 equals 336. Okay, so can we help ourselves out here any place? Can we divide 6 into 336? Let's see. 336 divided by 6, that's 5. Yeah, that looks good. 56. Okay, so 56 equals 7W. And we know that 56 divided by 7 is 8. So W is equal to 8. And what are my units? So the units on the pyramid, this is a distance. Remember, this is just the measure of this side right here. So the width, and everything is in inches. So my width is in inches. So W is 8 inches. Okay. Now let's see, are there any more of these? Nope, that was the last one. Okay, so if you have any trouble calculating areas of pyramids or of prisms, volume of prisms or pyramids, first thing you can do is go back and look at this video again, and you can always pause it and go step by step, but the formulas are real easy to remember. Volume is big B, little h, or for pyramids, 1/3 big B, little h, and big B is the area of the base. Okay, folks, if you have questions, I have office hours every day between 10 and 11, and you can just link into those office hours and see us face to face, and we can help you work through problems. All right, have a great day, and hope to see you soon.